Good morning, everybody. It's a great honor for me to be here, to be able to speak to you. EdMedia has been, for a number of years, one of my favorite conferences with some of the best speakers, one of the strongest communities. And in these 3 days, we hear many high-quality presentations giving us the latest update on the best practices, the results of studies and very practical information that we need in teaching and our research. But in my talk, I would like to talk to you more about the vision, about the future, about the new technologies and the new learning approaches that are coming with them, that are currently only emerging and we haven't yet had a chance to work with, or at least the greatest majority of teachers and researchers in technology-enhanced learning. So if you are coming from the education and learning, then I would urge you to think about the ideal, the best possible technology that you would need to realize your vision about the future learning, to realize your dreams about learning. And if you're coming from the technology background, I would urge you to think, what else can you do with the technology you work with, and how else you can benefit the society, and how else you can produce better learning outcomes for your students. If you're going to tweet, we have a special hashtag for the wearable experience, WECIT. So feel free to use it together with EdMedia. And I would like to start giving you brief information about what I'm doing. I currently have 6 projects, and today I'm presenting only one of them. As Catherine said, last year, together with a consortium of partners in Europe, I won a large research and innovation grant, and I work there as a project manager. I do very little research in the project that I'm presenting today, but I co-lead and manage this project. I also work as an associate professor. I also teach one course, and I have software development projects developing educational games and simulators. So now I would like to give you 2 examples, one from education and one from technology, of my personal experience that led me to wearable experience, to this large project that I work with now. How many of you are familiar with experiential learning, an experiential learning cycle? Some people. So then very quickly I'll tell you on the example that on one of my recent studies. It has to do with active learning, with certain learning activities that you give students a task or an activity, and they do this activity on the first stage, and then the next stage they would have to observe themselves performing this activity and reflect on their performance. And then at the next stage, they would do analysis, deep analysis, draw some conclusions and generalizations to realize their experience. And then after that, they're ready to go to apply this knowledge and this experience into a similar context in a similar activity. And here you see on the right-hand side of the slide, we gave them similar settings, but a different scenario 2. And then we did again observation, reflection, and then analysis, and this cycle can continue on and on. And the technological background, the technology I have been working with for nearly 10 years has been virtual reality and training with virtual reality. And a particular feature I would like to present is called the virtual reality recording. So virtual reality is a completely computer-generated environment that looks sometimes like our physical world, where students are represented as avatars and they can do certain activities here. You can see on the top floor is a classroom, and the blue figures are students, and there is one teacher and a whiteboard behind. And with virtual reality recording, we can capture such class in the virtual reality. It's relatively easy to do because the entire activity is done in a computer-generated environment. So it's easy to just track the logs of where each object was at a certain point of time, who said what at what point in time, what kind of objects were displayed and when they disappeared and so on, who moved where. So this all can be captured. And then you get a media content as a result that is different from any other media content we have. It's not a video, it's not an audio, it's not a 3D model, but it's all together working in dynamics so that you can go back and immerse in the replay, and you see here the orange avatars, they can just come and blend into the recorded class, and it's either themselves or other students, so they can observe themselves performing a certain activity. And then, of course, this observation can also be recorded again for later process analysis, and this cycle can go on and on. So as you can see, these two, this approach, experiential learning, and this feature of virtual recording, they work together very well. So this is just a couple of screenshots from a study in 2013 that we have done with a couple of my colleagues. So here you see students are working in small circles on their scenario. And then a week later, we gather the whole class in one circle to observe the performance of a certain group, a certain pair of students, and then we analyze their scenario, their role play, and then we go to the next circle and to the next. So this is how the experiential learning works in this example. Now let me go directly to the topic of this today's presentation. I'm going to introduce shortly wearable computing and augmented reality. And after that, I'll go to a new topic. I'm going to talk about experience, about learning experience, and about knowledge and knowledge conversion. And I will conclude with the WECIT training methodology that we are developing currently, and I will present you some of the initial results that we have. We are moving from information communication to experience communication. Throughout the history, we have been inventing different ways of capturing reality to preserve this as information bits and to pass it into the next generation, starting with writing and books, and now we have lots of media and technologies to do this work for us. But technologies like virtual and augmented reality especially provide much more possibilities to capture the entire experience. So with the smart glasses like Gear VR and with virtual reality glasses and Oculus Rift, for example, you can experience complete visually captured experience by another person. So if you capture somebody walking through a room with 360 camera and also record the sound, and then somebody would wear virtual reality glasses, this person will get a complete visual and audio experience of the person who was walking through the room with the 360 cameras capturing that. But that is little, because with augmented reality we can do even more. And I just wanted to demonstrate by a short video the Microsoft holoportation project.
Hi, today we're going to show you an exciting new technology that could fundamentally change the way that people will communicate in the future. Imagine being able to virtually teleport from one space to another in real time. Hey Sergio,
Yes, Ram.
how does it feel like to be holoported?
It feels great to be holoported.
So if Sergio is to wear his HoloLens device, and I'm going to wear mine, we can see each other in full 3D in real time. We can interact and communicate as if we're co-present. Sergio, can you walk around my space? Can you walk behind this chair? So we're doing everything to give the impression that Sergio and I are present in the same space. Sergio, let's just do a high five. That's
Bye
great.
bye.
Thank you, Sergio.
All right, I hope you get an impression what is possible to do with the current augmented reality technology, and Microsoft has released already their smart glasses, augmented reality glasses that would allow you to use this technology in your training. So for many years I've been thinking that augmented reality means that you are holding a mobile phone over a picture, the camera detects the picture and you get a 3D model on top of it. But as you can see from the Microsoft research, that it has been changed in the past less than 5 years dramatically, so it allows you to do much more nowadays. So this is the current state of the art in augmented reality. In terms of learning, it has been a trend for a long time that we are no longer interested in learning only facts about objects and phenomena, but we all want our students to learn about activities, about processes, about reaching objectives and goals. And together with communication of experience instead of information, we're getting towards performance augmentation. That in order to get experience through our perception of reality, with the augmented reality and wearables, we get a super real experience, because we get an additional overlay. Like in this example, we get another person teleported or overlaid in our experience. So wearable computing pursues an interface ideal of a continuously worn intelligent assistant that augments memory, intellect, creativity, communication, and physical senses and abilities. I like this definition very much because it talks about an ideal, a goal that we're trying to reach, and it's not yet as smooth as we would like, but this is what it will become very shortly, in just a few years, maybe even less than 5 years. We'll be able to get this technology into our houses, into our workplaces, and into our classrooms. And why not think today about how can we design learning for these technologies? So the motivation for developing wearable computing is very similar to the motivation that brought us from stationary PCs to laptops and then to mobile devices. So it's a better access to information, it's portability, but it also, in addition, enables hands-free operation. It can run continuously, it can attempt to sense the user context, and it provides the information very context-dependent. So the device would know where you are and what you are doing, and will give you information automatically, only that information that you need. There are currently a number of devices already in the market, mostly bracelets like smartwatch and bracelets measuring some of the bioinformation, but there are devices for different parts of the body sensing different data from the environment or from the body. Provides an enriched view onto the physical world, adding layers with contextually useful information, delivered visually or by stimulating other senses. So this definition has the key points that augmented reality is a technology that allows you to operate better in the physical world. So you don't need a computer-generated world, you work where you are, but it gives you a layer that would ideally be very smooth, that you don't even realize that it's computer-generated layer. And it gives you useful information, not barely a decoration or an augmentation of certain features of the environment. It gives you additional information that you wouldn't be able to get without the technology. And it's not only visual, even though the most popular augmented reality device is a smart glass, see-through smart glass, but augmented reality is aiming also to stimulate all other senses, or even generate new senses. The current developments in the augmented reality industry can be seen in a number of reports, and many companies are now getting into market and developing their devices. The market is growing. It's very small at the moment, but the growth is nearly 100% every year. And a number of predictions have been made that the market is going to explode in the coming 3 to 4 years. Here is another example of a conceptual video of augmented reality, and I would like to also show you a short video clip.
Vas tarde. Apúrate si quieres una buena calificación.
Voy lo más rápido que puedo.
¿Has pensado en correr?
¿Quién soy yo? es lo que quiero decir. ¿Para dónde voy? No. Adiós.
That is a concept of where the world would get with augmented reality becoming ubiquitous. So, but the reality is more rough at the moment, and we're not able to yet get our augmented reality to work as smoothly and as naturally as in a number of conceptual videos. But I will show you some working examples that are currently used in the industry, from some of my colleagues in Europe. Here is an example of an augmented reality system that gives an advice or contextual information about adjusting the voltage on a certain device. So it knows the current value of the voltage and knows the value that is needed, and it tells you where to adjust it and when, for example. And some of my colleagues have developed a vocabulary, augmented reality vocabulary that can be used in certain procedures in the industry, so to get an overlaid advice, contextual advice of what action is needed at what point in time. So here is the same example that it works on handheld devices, it works on the smart glasses. All right, so coming now from examples necessary to the project itself. It has been funded last year, and we just started less than half a year ago. And we started with the training methodology, and this is what I'm going to share with you today. We take the perspective that learning is a process of converting experience to knowledge. The information that is needed for a master level of performance, also known as theory, is usually separated from the immediate experience of performing this action, also known as practice. And traditionally, the key role in the conversion has been held by the skilled trainers or experts who are doing direct instruction or producing some media materials such as textbooks or video films. However, we all know that practice contains much more than what can be captured in textbooks. And it contains tacit knowledge, and which can be only shared through cultures and narratives and shared practice. And we in Technology Enhanced Learning have been developing various tools and methods to improve the textbook as a tool for converting the experience of the experts to the novices. And we've done great progress. However, this is just a substitute that we are using so that we, in many cases, cannot use the expert to the degree that we would like to. But the expert is unavailable, the expert is too expensive, and we cannot train all the novices to the level when they become the experts, and then we would need much more of the expert doing only training. And we believe that with wearable technologies and augmented reality that do not rely on separation of knowledge from its application, that we can capture much more of the experience and pass it towards the trainees or students, and that would open new opportunities for training and learning. That would also complete the experiential learning cycle if we capture the immediate experience, the practice of the expert very accurately, and we capture all the information that is needed from that experience, including and getting very close to the tacit knowledge, and we'll be able to capture it, store it as a new type of media, a very complex and rich type of media, and then we'll be able to share that to the trainees using augmented reality so that they can wear the experience of the expert when they do the same activity. So as a result, we would get an experienced learner, the learner who's being trained with and without the expert at the same time. So the idea would be to use the expert to capture him or her performing a certain activity only once, and then we've captured all the experience that would usually be needed when the expert is doing a direct instruction. And then this way we would go back to the master-apprentice type of training, but the master would be digital, would be captured, and the students will get the illusion, complete illusion, that the master or the expert is standing behind the shoulder all the time and giving the direct instruction. So this is the ideal, and this is the goal of our project, of our training methodology. Wearable experience training methodology aims to provide an innovative learning method that is based on the idea of capturing the experience of the expert and enabling the trainee to wear it while reenacting, thus giving the trainee the access to the tacit knowledge of the expert and enabling master-apprentice knowledge sharing. The methodology consists of 3 very simple stages: capture expert, reenact by the trainee, and then do an evaluation together. This is an example of capturing. This is a working prototype done already by some of our colleagues in the project. Here in this example, the student is facing a challenging task, and the expert, remote expert, who is not present, is giving him contextual instruction using their gestures. So you see the gray hands are of the expert who is not present at the place, and the expert will be able to point and to do whatever gestures are necessary to help the trainee to operate this device. So in this example, the capturing is done in real time. In our example, that would be captured once and then replayed at any time you need this procedure or need to operate this particular device. The reenactment example, you see here some industrial environment, and you see on the top it says a step 2, and you need to cut the fabric. So you see the overlay and a 3D model of the same machine that you see in physical world. If you just remove the glasses, you will see exactly the same machine. You put the glasses back, you will see the machine plus the signs, what you need to do and where exactly to cut and what to turn and so on. And these are the working examples from the industry. This is a university project for one of my colleagues who's developed a presentation trainer, and this is an example of evaluation. The idea is, the technology is very simple. It's capturing using Microsoft Kinect your gestures during your talk, and then you can watch it again and see, look at your gestures, and the system would help you to evaluate how you use your gestures. Are you making the points? Are you making the correct gestures when you're making the points? Are you using the correct gestures when you're concluding something or resetting your position and so on? We have done some literature study on capturing experience and using different technology for capturing and reenactment, and we've come up with 6 grand challenges. First of all, we looked at the level of abstraction, how much of the experience we can capture, because we cannot capture yet the entire experience, but there should be the right level of abstraction in the capturing. We need to look at the editing, if we need to remove something from what we've captured or add. We looked at the social scope and the interaction of humans in the captured experience. We looked at the sensors and the senses, what is enough, what is minimum that is enough to capture and of the activity of the expert, so the trainees can still learn from it. And this leads us also to the learning affordances, how much the learners will be able to learn from what we've captured from the expert. And then finally, we looked at the perspectives and then viewpoints. Here we looked at the expert taking the perspective of the trainee and the trainee taking the perspective of the expert, and both of them getting an illusion that they work as master and apprentice. So from the technology point of view, what is wearable experience? It's an experience that is facilitated by devices located on or in the body that includes tracking the user activity, biometric and environmental data using several senses, and then matching and mapping these into certain model of the activity, a very simple model, step by step, and then augmenting users' activity with another user's data. And here we're talking about augmenting the performance of the trainee with the previously captured performance of the expert. And then ideally the objective is to adapt and change the trainer's activity and the behavior and enable learning. In the project, we have three pilots, three industrial partners. One of them works in aircraft maintenance, and we're going to test the technology on the engineers who maintain helicopters and aircraft. Another one will work with imaging and diagnostics workers in healthcare IT, and also subsystem integration and operation in space. We work with the European Space Agency. One of the motivations for us to choose the industrial and workplace-based learning has been that the trend that computers and robots replace humans in the workplace, and manufacturing is one of the areas where some of the forecasts are predicting a very high rate of this replacement. And these studies has been done in the United States, in Europe, in Asia, and different parts of the world, and they give relatively same predictions. And this would lead people to a challenge that they would need to operate smart machines, and they would need to operate many more machines that they operate now. So the people would need to be able to learn very quickly how to operate a new machine and to fix or to maintain the existing infrastructure. Now, we're coming to the three phases of the methodology: capturing, reenactment, and review. And here is a little glimpse of how this is going to work in real time. So here we start with capturing. And we start with an expert performing an activity, and then we capture this activity in real time using wearable sensors, and then we pass it towards learning experience modeling and map it towards the description of this activity. And we'll be able to map it and match if the expert is going through all the stages, for example. But then the next step, the next phase when it's getting interesting, is that later on, we have the trainees, as many as we like. And then we start again with the trainee performing the same activity in the same physical environment, and we capture the trainee using exactly same methods, same technology, the same sensors as we captured the expert, and we pass that information towards the learning experience modeling. But in real time, at the same time, we would also combine the expert capture data and the trainee data, and then again in real time we augment the trainee experience with the previously captured expert data, so that the trainee is captured and also augmented at the same time. And later on we can go to a phase where together trainees and the expert can review, analyze, compare, and evaluate and assess their performance. And here we're talking about not only debriefing and watching their performance, but we're also talking about lots of data and analytics that we'll be able to get access to, because when we capture the expert, we will capture the speed and the precision and the psychological state that the expert is probably going to work normally and calm, and the trainee might be making mistakes. And collecting the data and matching that to the data of the expert, we'll see exactly where the trainee is working slower, for example, or making mistakes. And we collecting the data, some biological data, we will be able to tell that the trainee is doing mistake because he is nervous, she's nervous, because they are unfocused, or because they are too tired, or we'll be able to give a semi-automatic review and analysis of the activity and training. So the goals of the methodology are to capture the expert experience, to capture the expertise, then to enable the reenactment of this expertise. Then we'll be looking at the design of learning tasks looking at how exactly we should design the whole process, the whole training process for such technology, and then we would generate requirements for the technology. So we start with the learning, with the training methodology, and then we will adjust the technological development of the system. Well, we started an interesting process looking at the experts, and we found that there is lots of literature about the experts and their qualities. So we found some of the positive qualities of the experts. For example, they have superior mental knowledge, they have lots of experience, and they are able to map the current situations into their previous experience very quickly, very easily. They have better perceptual abilities. They can spot the visual cues or any other cues in the environment, and they can detect what is going on very quickly without even thinking. They are doing much better qualitative analysis of the situation to take better decisions, and they apply better strategies, and to perform all that, they require very low cognitive effort. So it happens automatically. But at the same time, there are some shortcomings. The knowledge of experts is usually very domain limited and inflexible, and they usually fail to recall the surface features, and there are too many aspects that they think are easy, and they cannot understand anymore that there are certain things that can be challenging and difficult to understand for the novices. And therefore, they are very often doing inaccurate prediction and judgment and give wrong advice to the novices. They're also inflexible and often biased. Then, to construct the methodology, we apply two approaches, a bottom-up and a top-down. In the bottom-up approach, we start with analyzing concrete tasks in the industrial settings, starting with our pilots and looking at other industries. And then we classify them according to the common scheme, identifying aspects of expertise. So where is exactly the expertise, and how to enable learning there. Then we try to find the mechanisms with augmented reality and wearable technology. How can we support the expertise transfer? And in the top-down approach, we identify tangible and intangible aspects relevant in all tasks, and then trying to find key aspects and key factors in rating scheme, and then assess tasks and mechanisms according to factors and schemes by experienced experts, for example. So this is an example of the bottom-up approach. We have a number of tasks on the top, such as high precision, high speed, decision-taking, collaborative tasks, and so on. And on the left-hand side, we have the transfer mechanisms, what technology can allow us to do, such as slow motion, zoom in, think aloud protocol, contextualization, and so on. These are examples that we found in the industry. You see some of them are more popular than others. And in the top-down approach, we looked at the tasks, domains, and dimensions. The tasks we classify into perceptual, cognitive, and developmental domains, human, machine, and environment, and dimensions to space, time, and target. I'll give you an example. If an astronaut is performing a psychological stress test, this is a cognitive task, clearly. But if at the same time he is operating a robotic arm, then the domain would be machine. And then if it all happens in a very time-limited context, then the crucial dimension would be the time. And now I would like to conclude the presentation with a little bit of romantic and lyrical part. So the project is truly a community-driven project. TEL stands for Technology Enhanced Learning. Why? The idea of wearable experience was born in a summer school for PhD students, which I attended, and I attended a workshop on augmented reality. Augmented reality wasn't really my number one expertise at that time. It was shortlisted, but I was working with other technologies. And we were split into teams, and I was in team number 4, and there were only 4 teams, and I was alone in my team, and nobody really believed in this idea. But I had a conceptual photograph that you can see here, Actually, this photograph inspired my colleagues to do the ghost hands example that I showed before, so they actually realized that, implemented this. And I started to work on this idea, and this idea was supported at least by the person who organized the workshop at the summer school. And then the next year, the same summer school, we have already had a proposal submitted to the European Commission for a large grant. And if you can see here, the competition was really tough. It was only 3 proposals funded out of 174 applications. And last week, we had another summer school, the same summer school for PhD students in technology enhanced learning, where we had 4 different sessions where we were brainstorming and training and working on cases with PhD students on using wearable and augmented reality technologies. But as I said before, this is a collaborative project, a European collaborative project. We have 13 organizations working together. And here you can see the list of these organizations, and among the 13 of them, 7 are really the summer schoolers. They're coming from the same community on technology enhanced learning. In the community, we are taking the approach of working together with all sorts of stakeholders, with developers of technology, with the users of the technology, with industries, with training industries, with IT and hardware developers. And we are applying a methodology. It's called social requirements generation, and we have a community portal where you can, if you have any ideas about the use of augmented reality in the industry, or if you have any ideas about the training methodology as I described it today, you can post a very short description of your idea on our community portal, and if this idea would be rated highly, we will implement your idea. So we are working with ideas of people, and we are also working with requirements. We go into the industry and ask them how to make the technology compatible with what you currently have. And we go into the trainers and we ask how can we make the training methodology compatible with your current training practices. We also have presence on the social media. Feel free to follow us on Facebook, Twitter, and other places. And if you have any questions, then we don't have time for questions. You are free to tweet your questions with the WECIT hashtag, and someone from the community or me will be happy to answer any questions.